Dear student, myself Dr.S.Sukumar, Assistant Professor, Department of Environmental Science, Behavioral Ecology, Trichy, Tamil Nadu. Today we are talking about concept of remote sensing technology. So definition of remote sensing technology. So without going to field, we can extract a particular area topographical features. For example, if you wish study any district geographical features, you can download free cost of satellite imagery. Using satellite imagery, you can extract the earth features. So this technology is called remote sensing technology. Remote sensing technology is very highly useful for environmental studies student. The remote sensing technology has three important platforms. Number one, ground level platform. Number two, aerial platform. Number two, space phone platform. So in ground level platform like cranes and towers. Number two, aerial platform like helicopter, high altitude aircraft and low altitude aircraft. And third one, a space platform like subtle geostationary satellite and a polar orbiting satellites. So this is the altitude of some platform. The first from the earth surface above the 150 meter, we can operate a drone platform satellite remote sensing, and 1 to 1.2 kilometer to 3.5 kilometer we can operate the aircraft, and 700 kilometer to 900 kilometer we can operate the satellite. So these are the schematic diagram of platform, satellite remote sensing platform. So second one, principle of remote sensing, how it is functioning. The remote sensing technology based on the electromagnetic radiation, EMR recording. So this is simple schematic diagram of how it is functioning, how we can get satellite imagery using remote sensing technology. The first one, energy. The A is the energy. The energy following the earth surface. After the energy following the earth surface, after following the energy, immediately the energy reflected towards the satellite direction. That is the B. C, number 3. Interaction with the object. C is the interaction with the object. Number 4, recording the energy by the sensor. There's already they are kept the sensor in satellite. Okay, the satellite sensor capturing the all reading. So this is the simple diagram of electromagnetic radiation. Sun is the main source of energy. The main source of energy are recording by the satellite sensor. So visible range of electromagnetic spectrum starting from gamma rays and end of the radio waves. In particular distance we have to use EMR. So second point, sensor. So sensor is the very important platform, important point for remote sensing technology. The sensor based we can classify the satellite image accuracy. So by the way, type of sensors, we have two type of sensor. Number one, active sensor. Number two, passive sensors. So what is the meaning of active sensor? The active sensor create their own energy working for day and night, but passive sensor depends upon the external energy. A satellite itself have their own energy. The satellite energy are sending the light source to the ground surface. That is the major difference. So what is the difference between active sensor and passive sensor? Energy only is the major difference. Active sensor have own energy like sunlight. Active sensor based on the working for sunlight energy. Passive sensor based on the working for satellite energy. Already have the satellite have energy. So best example of active sensors, radar and lidar, and passive sensor best example for Landsat, LIS-3 and Spot heavy satellite imagery. So this diagram illustrate active sensor and passive sensor reflectance and recording system So first sensor is the sun energy following the ground surface and ground object. Immediately the energy are reflected and environment. So these energy are captured. So this is major difference between active and passive sensor schematic diagram. So the sun satellite have own energy. The energy sending to ground, immediately the energy are reflected towards the satellite. So already the satellite have sensor that sensor capturing the reflected energy. Okay. So after that we can create the satellite imagery. So best example of active sensor radars are, this is the satellite imagery, example of active satellite imagery. So altitude from the Earth surface 798 kilometers, this radars are satellite altitude height is 798 kilometers from the Earth surface. So orbit orbit period 100.7. So repeativity days, so each and every 14 days we can extract the satellite, this radar shot. So this is list 3 satellite image, example of passive remote sensing technology, passive sensor, example satellite imagery. So this satellite imagery taken from the Earth surface 817 kilometers. Now the center is ISRO, Indian Space Research Organization, and the National Remote Sensing Center. So they are taken the passive sensor remote sensing technology. This is the sensor. You can see the sensor. So third point, orbit. So previously we have to discuss sensor. So now we have discussed orbits, satellite orbits. So 3 satellite orbit is this: LEO, MEO and geostationary. What is meaning of LEO? Lower Earth orbits, lower Earth orbit altitude range 500 km to 200 km from the Earth surface. So this is lower Earth orbit range. So next one, MEO, medium Earth orbit. What is the height from the Earth surface? Medium height Earth orbits from the Earth surface 2000 km to 36,000 kilometers. A very vast area. This is medium Earth orbit. So application of medium Earth orbits, application of medium Earth orbit are using primary navigation purpose like GPS. So our GPS in our camera also having GPS technology. So these our mobile phone GPS app also interact medium Earth orbit satellite. So major use of medium MEO, medium Earth orbit satellite imagery, navigation purpose like GPS. So understanding third orbit, geostationary orbit satellite. So what is the uses of geosatellite orbit? Then the remote sensing technology are classified in major 2 types. One is microwave remote sensing and thermal remote sensing. So in our environmental science department, majorly used for microwave remote sensing. So application of remote sensing technology is very useful for our student, especially environmental monitoring student. So using remote sensing technology we can understand, we can monitor, change direction is possible, weekly, monthly, yearly, and date-wise we can monitor the land use land cover changes. By the way, major uses of remote sensing technology, coastal application monitoring shoreline changes, shoreline changes monitoring is possible, ocean application monitoring in circulation, current system, so current system measuring, hazard assessment tracking hurricanes, earthquake, erosion and flooding damage assessment is possible. Natural resource management monitoring, land use mapping, wetland and charting wildlife habitats monitoring is possible. Forest fire, we can using 2 seasonal imagery for the same area, forest fire mapping also is possible. Land cover, detecting land use land cover changes is possible using 2 different year satellite imagery for the same area, for the same study area. Land use, land cover changes also is possible. As well as we can calculate the area calculation is possible. How many forest area or deforestation, how many square kilometer or urbanization growth, that is also possible using remote sensing and technology. So climate change is possible, observe climatic changes is possible. So these are the major application of remote sensing technology. So dear student, the remote sensing and technology is the very useful for a geographic student, environmental studies subject student, geology students. So all the earth monitoring researcher also they are used this technology. So remote sensing technology is very useful for research and change detection technique. Thank you.